Hello everyone, I am Balram Tamrakar, Assistant Professor at EC Department, KIET Group of Institution, Ghaziabad. In this video lecture, we are going to discuss ramp and parabolic response of first order control system. Okay? Now come with the contents. In the content, we have basic two terms. First one is the ramp response of the first order system and second one is the parabolic response of the first order system. That means if the input is subjected to ramp or parabolic, then in this particular video lecture we are going to discuss the output response analysis about if unit ramp or unit parabolic input signal subjected. Clear? So come with the content. So after that, consider the unit ramp signal as an input to the first order system. So in this particular case, RT is equal to T into UT. Look, that is the function T into UT. So take the Laplace transform of this particular term, then it becomes 1 by S square. Clear? Now we know that in the last lecture we calculated the response for first order system and calculated CS value when subjected to unit step. Now subjected to unit ramp. So 1 upon ST plus 1 multiplication with the RS, and RS is 1 upon S square. How we are getting 1 upon S square? We are taking the Laplace of RT. So it becomes RS. Now substitute RS is equal to 1 by S square in this particular equation. So we will get this one. CS is equal to 1 by ST plus 1 multiplication with RS, 1 upon S square. So after multiplication we are getting like this one. Okay. After that, what we have to do? Do the partial fraction. After applying partial fraction like A upon S square plus B upon S plus C upon ST plus 1. So after simplification, we will get all the coefficient value of partial fraction A, B, C and substitute. After that we will get, okay. Now calculating all the values, that is the simplification of this particular partial fraction expansion. So after getting all the values, come with the next slide, this one. This is the CS output response in S domain after applying partial fraction. So simplify this particular term. After simplification we are getting this last term T square and ST plus 1. So take the common T value, capital T, it will S plus 1 by T. Why I am doing this one? To arrange in such a way so that its inverse can be easily taken. Okay. So CS in a simplified form, this one. After that take the inverse Laplace. So we will get CT. Come with the next. Look this particular expression CT is equal to T minus capital T plus T into e raised to power minus T upon capital T whole multiplication with UT taken as a common value. So that is the response when input is subjected to unit ramp. Okay. Now there are the two different terms. The unit ramp response CT has both the transient and the steady state terms. This one. Now the transient term in the unit ramp response can be given by this particular relation. Capital T e raised to power minus T upon capital T into UT. That is the transient term. Okay. Now the steady state term in the unit ramp can be expressed by this particular relation. T minus capital T into UT. We have to remember both terms. Now come with this particular diagram. What about this diagram? That is the response between CT versus T. If you are sketch with the help of this equation, then we will find like this one. Okay. Now what is this one? RT is equal to 2 into UT. That shows our output response when subjected to unit ramp. Okay. So in this particular slide we seeing response of the system, transient term, steady state term. Okay. Now come with the next. That is the another response, similar response, but look about the outcome. That is the outcome. The unit ramp response CT follows the unit ramp's input signal for all positive values. But there is a deviation of capital T units from the input signal. But there is a deviation. In this particular diagram, both terms, if we are seeing that is the actual slope, dotted line, having a practical slope. Clear? So that is the outcome. Clear? You have to remember that is the outcome regarding ramp. Now come with the next. Okay, next one is the parabolic response. Suppose we have a parabolic input signal and it is subjected to control system, then what about? Here the input signal is t square by 2 into ut. Clear? Act as a parabolic input. Take the Laplace of this one. It becomes 1 by s cube. Now again consider this particular primary equation for first order. 1 upon st plus 1 into rs. Apply the value of rs here and again do the partial fraction and take the inverse Laplace transform. So substitute the value of rs. Okay, come with the next. That is the parabolic input. Now again look this particular equation. Here we have put the value of sequence, that is the rs, 1 by s cube. Now again I am applying the partial fraction. So you know about the partial fraction. So we have to apply the partial fraction and calculate the value of a, b, c, d. So after calculating all the values, we are getting this particular term cs. This one cs is equal to this one, 1 by s cube minus t by s square and so on. Clear? So after simplification we will get the last term, this one. Clear? Now come with the next. Take the inverse. Okay, apply inverse Laplace transform on both sides, then we will get this equation. Here also you have ut taken as a common value. So that is the response or output when subjected to unit parabolic function. Now the unit parabolic response has both terms, transient and steady state. So what is the transient term in this particular case? This one. That is the term indicated for transient analysis or response, and that is the second term, the steady state term in the unit parabolic response given by this relation. Okay, so in this slide we have to remember 3 points. First one is the output, transient state analysis part, steady state analysis part. Okay, now come with the next. Look, after simplification of ramp and parabolic come with some fundamental numerical which belongs a simple analysis of RC circuit. Here RC indicated for the if you have a series resistance with the series capacitance. Capacitance having voltage value Vt approaching with the current It and applying voltage is the Vt. V subscript capital T. Clear? Now if we have a simple RC circuit, then apply a Kirchhoff voltage law inside or applying a mesh analysis. So we will get RIT plus VT is equal to VT of small t. That is Kirchhoff voltage law analysis. Now represent this particular equation with respect to IT. Okay. So IT becomes this one. We know that it's a C dV by dt. Now after simplification we will get this particular equation. That means IT is C dV by dt. Replace the value of this one into this particular equation IT. So it equation like this one. Here VT is what? VT is the state variable. This one state variable, and this one is the input waveform. Clear? Now come with the next. Okay. In this particular analysis of RC circuit, step input response. So what about step input response? If this circuit is subjected to step response, then what will happen? Look, here I am applying V naught ut. Okay. Now after simplification, how we can get simplification? Again apply all these parameters and simplify, take the solution of this particular differential equation, then we will get Vt is equal to K times e raised to power minus t upon Rc. That is a simple analysis. I think everyone read in the network analysis subject how we are getting. Clear? Now, so it will plus V naught ut. So match the initial state. V0 is equal to 0. So after simplification, after applying initial values, so we are getting these constant terms. Okay, K plus V naught is equal to 0. Now output response for the step input is Vt is equal to this one. V naught 1 minus e raised to power minus t upon Rc into ut. Clear? What is Vt? In previous slide, look this one. That is Vt, that is the voltage across capacitor, while Vt of t is the applying input voltage. Clear? So come with that is the response. That is the response V naught versus t. That is the V naught versus t diagram. So in this particular diagram, again we are seeing about the transient state and steady state analysis. After applying a 40 time interval, I am again saying 40. 40 is what? T is the time constant. After 40 time constant, the response will approach to the steady state response. Okay. So 98% response approaches at 40 interval. There is a plus minus 2% difference. Okay. So after 40 interval, the steady state will comes. That response also indicated. Now come with the next RC circuit. So that is the total a numerical, you can say that, in which Vt is this one. Okay. Under step input signal, Vt is the 0.5 Vt, where t is the 0.69 Rc. That is delay is the 0.69 Rc, 50% delay. Vt is equal to 0.1 V naught, where t is the 0.1 Rc. Vt is equal to 0.9 V naught, where t is the 2.3 Rc. That is rise time 2.2 Rc. Rise time here is not indicated, but I am just indicating about the rise time. Rise time is the time needed to reach response from 0 to 100% or 10 to 90%, depending upon the underdamped or overdamped condition. We will discuss later. Clear? So come with the next. Now in this particular case or in this particular example, we have to calculate, that is the CT, and find out time constant, DC gain, transfer function, step response. Clear? Now if CT is this one, then CS, that is the first order control system's output, input multiplied by 1. So simplify this one. After simplification, we will get CS upon RS like this one, 3 upon S plus 0.5. Now come with the next. do the simplification and we will get 6 upon 2s plus 1. Here 0.5 taken as a common value. So after simplification we are getting 6 divided 2s plus 1. Now again similar example. Okay, so we are not discussing with this particular term because that is the similar terms. Also in this, time constant is 2, DC gain is 6, transfer function like this one. So come with the next. That is the another representation to find its accurate solution, in which CT is this one. So integrate both terms, LHS, RHS both having an integrator. Now after simplifying this one, the solution is CST is equal to minus 6 e raised to power minus 0.5t plus capital C. We can find out C if initial condition is known, that is, suppose here this term is 0. Now after applying initial conditions we will get the value of constant C. Look, after simplification we will get 6 value. Clear? So put the value of C in this particular equation, then we will find the final solution. Clear? Thank you very much for watching this video.